In this video, the Protection Graphic Assistant is demonstrated. This tool can be used to visualize the zone reach in a single line diagram or to create short-circuit sweep plots of internal relay variables such as impedances or directional angles. Study case 07 protection should be activated. We'll concentrate on the northeastern part of the network. Here, each line is protected by two distance relays. To see the relay configuration, we can select one of the cubicles and show the devices. The relays are configured with three main tripping zones and an overreach signaling zone. Now, if we want to look at the zone reaches, we could open a time distance plot. But we can instead use the Graphic Assistant to color the single line diagram according to the impedance reach. The command is opened using this icon in the Protection and Arc Flash Analysis toolbox. Create Reach Coloring is selected, then we have to select the devices for which the coloring is to be displayed. Let's choose two relays from the northeast grid. Under the page Reach Coloring, the coloring can be selected. We'll choose different brush styles in order to distinguish between the two relays, then execute the command. The coloring indicates the reach of each protection zone. From the red coloring for Zone 1, it can be seen that the first zone reaches about 85% of the first line. Let's now calculate a single phase to ground fault at the end of line NWN-EL1. According to the reach coloring, the relay is set to trip in the second zone, but due to some network effect, it trips in 1.2 seconds. Let's examine this effect, which causes the relay to trip on its first protected line after the delay of the directional starter. For this purpose, we'll use the Protection Graphic Assistant again to create a short-circuit sweep plot of the reactance seen by the relay. First, we need to define a protection path for the short-circuit sweep. The first and last nodes and the line are selected, then the path can be created. Returning to the Protection Graphic Assistant command, we'll select the option Create Short-Circuit Sweep Diagrams. We select the relay we want to examine. On the SC Sweep Diagrams page, the path has to be selected. And there are options for the internal variables to be displayed. As we're calculating a single phase to ground fault, the loop selection is set to Phase to Earth. The command can now be executed. There's a plot for each polarizing block of the relay, but we'll focus on the top plot and delete the other one. In the remaining diagram, the calculated phase to earth reactance is shown. Let's have a look at the reactance for phase A and add the threshold of Z2. Normally, we would expect a linear rise of the reactance along the line. The reason for the observed behavior lies in the line coupling. If we take a look at the line definition, we see that there is a mutual coupling defined. This causes the reactance, in the case of a single-phase fault, to rise exponentially. We can put the parallel line out of service and repeat the calculation. The reactance now rises linearly with the line length. One possible solution for the nonlinear behavior could be a mutual CT located on the parallel line to compensate for the relays underreaching.